Good morning. Today we continue with the derivatives of parametric equations. We say that, okay, just a moment. Okay, so we say that with these parametric equations, you look at your x and y, which are in terms of another variable, let's say t, where t is our parameter, and we want to find the derivative of y with respect to x. So we started on exercise 1.6, so we'll continue with that. And let's look at number 2. So number 2, we have x is equal to sine squared of theta and y is equal to sine of theta. So with these questions, what we are trying to find is dy dx when x and y are in terms of a parameter theta. So we know the formula for dy dx. This is given by this formula dy d theta divided by dx d theta. So you work out each of these and then just divide and get your answer. Then we have a similar formula for the second derivative. So dy d theta, this is y, differentiate this with respect to theta, we get cos theta. And then dx dy, differentiate x with respect to theta. So this is 2 sine theta. Then you multiply by the derivative of sine theta, which is cos theta. So dividing this, we get 1 over 2 sine theta, which is the same as cosec theta over 2. Okay, then to get the second derivative, d2y dx2, what we need to do is differentiate with respect to theta our dy dx, and then again divide by dx d theta. Now dx d theta, we already worked it out. There it is. So we don't need to work it out again. We'll just reuse it over here. So what we need to do is differentiate this one. So with these questions, because they are your answer here depends on what you get over there, make sure what you do over here is correct, because if that is wrong, that's going to affect what you get over here. So this is equal to the derivative of this with respect to theta. Remember, the derivative of cosec is cosec cot, and it's negative because it starts with a c. So we have half cosec theta cot theta, and then we divide by dx d theta. Dx d theta is 2 sine theta cos theta. Divide by 2 sine theta cos theta. And always leave your answer in its simplest form. Cancel whatever it is that you can cancel. And let's see, this is minus. Okay, so that's minus 1 over 4. So that's the half divided by the 2. And cosec is 1 over sine. So you'll get, when we divide it by sine, we'll get cosec squared theta. And then cot is cos over sine. So the cos at the top will cancel the cos at the bottom, and then you'll be left with sine in the denominator, so this should be cosec cubed. Okay, so let's just see again. So cosec, that's 1 over sine. Here you're dividing by sine, get sine squared. Cot is cos over sine. So there's another sign in the denominator to make it cosec cubed. The cos in the numerator cancels with that one. Okay, so that seems right. Change this. So this is negative 1 over 4 cosec cubed theta. Okay, then let's look at number 4. Before we have x is equal to 2 plus 3 sine t and y, somebody speaking, 2 cos t. Okay, if you're not saying anything, please just mute your mic. The background noise is quite disturbing. Okay, then we want to work out dy dx as usual, and also the second derivative of y with respect to x. So doing that, we know that dy dx, this is equal to dy dt, because here our parameter is t, and then we divide by dx dt. So simple calculation over here, dy dt. So this is our y. We differentiate this with respect to t, so we get negative 2 sine t. And then dx dt, we differentiate this with respect to t. The derivative of 2 is 0, and the derivative of sine is cos, so we have 3 cos t. And in its simplest form, this is just negative 2 over 3 tan t. Then the second derivative, d2y dx2, say the formula is to differentiate with respect to t the first derivative of y with respect to x, and then this is divided by the derivative of x with respect to t. So doing that, our answer in the previous part, we differentiated with respect to t. We know that the derivative of tan is sec squared, so we have minus 2 over 3 sec squared of t, and then dx dt, which we worked out over here already, is 3 cos t. So we're dividing by 3 cos t. So you always want to leave your answer in its simplest form. So this is negative 2 over 9, and we know that cos, dividing by cos is the same as multiplying by sec. So our answer should be negative 2 over 9 sec cubed of t. Okay, it's number 4. Then number 6, we have x is equal to 3, 1 minus cos theta. Yeah?
Go back.
Yeah. Did you say something? I didn't quite get that. We have 3 theta minus sine theta. So again, we want dy dx this is dy d theta dx d theta. So differentiate y. This is 3 multiplied by 1 minus cos theta. And then we divide that by the derivative of x with respect to theta. So that will be minus, that'll be 3 sine theta. Okay, so then we can simplify. The 3's will obviously cancel. So this is 1 minus cos theta over sine theta. And because we know we're going to have to differentiate this in the next step, you can always write it as cosec theta minus cot theta, which is easier to differentiate than trying to use the quotient rule over there. Maybe not that much easier, but I guess a little bit easier than using the quotient rule. Then we work out the second derivative. The formula, as we know, we need to differentiate with respect to theta the first derivative of y with respect to x, and then divide by the derivative of x with respect to theta. So we differentiate this function here. The derivative of cosec is minus cosec cot. So we have minus cosec theta cot theta, and then the derivative of minus cot theta is positive cosec squared theta. Okay, so this whole has to be divided by the derivative of x with respect to theta, which is 3 sine theta. Negative, no, it's not negative, it's positive. Okay, so we can rewrite this cosec, try and simplify it as far as possible. We know that cosec is 1 over sine, and cot is cos over sine. Then we divide that, let me just write what I'm saying. This is minus cosec theta cot theta over sine theta, and we have cosec squared theta over sine theta. Okay, so if there are any terms that can cancel or be combined, then you can go ahead and do that. So we say cosec is 1 over sine. So in the denominator, we will have sine squared. So we have minus cot theta over 3 sine squared theta. And for the second one, we say that cosec is 1 over sine, and here we have 1 over sine, so that's cosec squared divided by, multiplied by cosec, so that's a third cosec cubed theta. Okay, so can you leave it like that as your final answer? over 6. Let's look at number 8. Number 8, we have x is equal to cos 2 theta, and y is equal to 1 plus sine 2 theta. So we say that dy dx, this is equal to dy d theta, and divide this by dx d theta. So dy d theta, here is our y, we differentiate that, we get 2 cos 2 theta. Then we divide by the derivative of x with respect to theta. This is negative 2 sine 2 theta. Okay, so we're dividing, so the 2's will cancel, and what we get is negative cot 2 theta. Okay, just see what the question says. Okay, determine the equation of the tangent. Okay, so we wanted the equation of the tangent, not just the derivative. But remember, the derivative gives us the gradient of the tangent at that point. So where theta is equal to pi over 2. So our gradient, which is dy dx, and we want at the point where theta is equal to pi over 12. This is negative cot of 2 times pi over 12. Okay, so when it's pi over 12, that tells you that that is in radians. So this is equal to negative cot of pi over 6. Okay, pi over 6 is 30 degrees, and cot is the reciprocal of tan. So if you remember from your triangle, tan of 30, this is 1 over the square root of 3, or square root of 3 over 3. Okay, so the reciprocal of 1 over the square root of 3 is just negative square root of 3. So now we have our gradient for the tangent. We just need a point that lies on that line. So we know that theta is equal to pi over 6, so we can work out the x coordinate and the y coordinate. That will give us the point on the line, and then having the gradient and the point on the line, we can work out the equation of the line. So we say
Yes, how
that
did you get that answer?
which answer?
Negative square root of 3.
That is what cot of pi over 6 is equal to.
Oh.
Like if somebody says, what is sine of 30? The answer is half. That is what it is. You can type it in on your calculator. Okay, so we say that when theta is equal to pi over 12, we can work out the x coordinate. So this is x that is defined to us in the question. This is cos of 2 times pi over 12. So that's cos of pi over 6. Cos of pi over 6 is the square root of 3 over 2. Okay, and then y is given to us over here. It's 1 plus sine 2 theta. So this is 1 plus sine 2 times pi over 12. Okay, so that is just 1 plus sine of pi over 6 is a half, so we have 1 plus a half, which is 3 over 2. So now we have our gradient, we have the point, we can work out the equation of the line. So the tangent here has a gradient of negative square root of 3, and it passes through the point square root of 3 over 2 and 3 over 2. Now the equation of the line. So we know we can use the 1-point gradient formula. So we say y minus y1, this is 3 over 2. Our gradient, negative square root of 3, and then x minus x1 square root of 3 over 2. And it's always good to leave the answer in standard form, y is equal to mx plus c. So what did I get? You got y is equal to minus square root of 3x. Then this times that is positive. Then I have 3 over 2 plus 3 over 2, which is just 3. Okay, so that is the equation of the tangent. Just see. Question said, determine the equation of the tangent at the point this. So we can say that the equation of the tangent at the point where theta is equal to pi over 12 is y is equal to minus square root of 3x plus 3. Okay, then number 10 says determine the coordinates and nature, that is maximum or minimum of the turning point of the graph y is equal to f of x between theta is equal to 0 and theta is equal to pi, if x is equal to minus cos theta and y is equal to 2 sine theta. So remember, at the turning point, our derivative is equal to 0. Then to test whether it is a maximum or a minimum, you find the second derivative. A negative second derivative at that point tells us that it is a maximum, and a positive second derivative tells us that it is a minimum. So all those things we did, you need to keep them with you. So we're looking for the turning point. So we know that at the turning point, dy dx is equal to 0. So first we find dy dx and then equate it to 0. So we know that dy dx, this is equal to the derivative of y with respect to theta divided by the derivative of x with respect to theta. So this is, here's our y, we differentiate this, we get 2 cos theta, and then differentiate x with respect to theta, the derivative of minus cos theta is sine theta. So this is 2 cot theta. Okay, so we're looking for the turning point. So at the turning point, we say this is equal to 0. We say that 2, say at the turning point, 2 cot theta is equal to 0. So remember that cot theta is 2 cos theta over sine theta is equal to 0. So this means that cos theta is equal to 0. And this means that theta is equal to pi over 2. And the reason there are more answers for which cos of that angle is equal to 0, but according to the question, we need to restrict our solution to an answer between 0 and pi. Okay, so this must be an angle between 0 and pi that is told to us in the question. Otherwise, there's more than one turning point for this graph. It's not just pi over 2, but this is the one between 0 and pi. Okay, so now that we know what the turning point is, we need to determine its nature. That is it a maximum or a minimum? So to determine the nature of this turning point, we look for the second derivative. And we know that the second derivative, this is given by the derivative with respect to theta of dy dx divided by dx d theta. So this, just write it. This is just the derivative of dy dx with respect to theta. The derivative of cot is minus cosec squared. So we have minus 2 cosec squared of theta, and then we have to divide by dx dt. And what is dx dt? We worked it out over here. This is sine theta. So remember, dividing by sine theta is the same as multiplying by cosec. So this is minus 2 cosec cubed of theta. So that is our second derivative. Then what we would do to test whether this is a maximum or minimum is we would substitute our turning point into the second derivative, and then depending on whether it's positive or negative, we can state whether it is a maximum or a minimum. Okay, doing that. Okay, this is just negative 2 over the sine of pi over 2 to the power of 3. So we know that cosec is 1 over sine, so cosec cubed is 1 over sine of theta cubed. So our theta is pi over 2, and then you cube it. And this is negative 2, which is less than 0. And therefore we have a maximum. And the question said, what did the question exactly say? we need to determine the coordinates. Okay, so we need the x coordinate and the y coordinates. So we know that it is a maximum. Now we need to find out what are the x coordinates and what are the y coordinates. So we say that when theta is equal to pi over 2, the x coordinate is given by here minus cos of pi over 2. So this is minus cos of pi over 2, which is just 0. And the y coordinate is 2 sine pi over 2. It's 2 sine pi over 2, which is 2. So we have 0, 2 is a maximum turning point. That is how you should answer that question. For number 12, we are told that the movement of a particle moving with damped vibrations is described by the formula y is equal to e to the power of minus t sine 2t, and y is the displacement of the particle during time t from its neutral point. Show that y is a maximum if t is equal to half arctan 2, and determine the maximum displacement to 3 significant figures. Okay, so for 12, we have our equation y is equal to e to the power of minus t sine of 2t. And this one here, we're not really using parametric differentiation because this is an equation that is in terms of only one variable. So it's just ordinary differentiation, or straightforward anyway. So we find the first derivative because we're looking for the maximum, and at the maximum we know that the derivative is equal to 0. So differentiating this, we have to use the product rule. So product rule is the first one as it is. So we have e to the power of minus t multiplied by the derivative of sine t, which is sine 2t, which is 2 cos 2t. And then the derivative of the first one, which is negative e to the power of minus t, and then that is multiplied by the second one as it is. Okay, we can write this simpler so it looks neater. So this is e to the power of 2 e to the power of minus t cos 2t minus e to the power of minus t sine 2t. So we know that at the maximum, the derivative at the derivative dy dt is equal to 0. So we will equate this to 0 and then solve as far as possible. So we have 2 e to the power of minus t cos 2t minus e to the power of minus t sine 2t is equal to 0. So we can see that e to the power of minus t is a common factor, so we can factor that out. So e to the power of minus t, 2 cos 2t minus sine 2t is equal to 0. So two terms here are multiplying and the answer is 0. So this means that e to the power minus t is equal to 0, or 2 cos 2t minus sine 2t is equal to 0. For the first one, we know that this is invalid. So ordinarily I wouldn't write it, but looking at memos of tests, there's always a mark for stating that it is invalid. So go ahead and write that. Right, then we look at this one. Last semester we looked at how to solve trigonometric equations. This is an example of one that you should be able to solve. So we have 2 cos 2t minus sine 2t is equal to 0. We can divide throughout by cos 2t. So we have 2 minus tan 2t is equal to 0. And this means that tan 2t is equal to 2. And then solving for t, we get that t is equal to a half tan inverse or arctan of 2, which is what we were actually asked to prove or to show. Yeah. Then the second part was okay, it would, I guess, be a good idea to show that it is in fact a maximum by getting the second derivative and then substituting it in there. So that you can do for yourself. Find the second derivative, or you just to confirm that it is in fact the maximum. So just because the derivative is 0 does not necessarily mean that it is a maximum. The reason I said it is a maximum is because we're guided in the question, but I think in the test we would want you to show that the second derivative is in fact negative. So you'd work out the second derivative and substitute that into the second derivative and show that your answer is negative. So it is in fact a maximum. Then we want the maximum displacement. So we have the formula for the displacement. Y is equal to e to the power of minus t sine 2t. Now we want to write that to 3 significant figures, and we know that t is half tan inverse of 2. So we just substitute our maximum displacement. We have y is equal to e to the power of minus t, so e to the power of minus a half tan inverse of 2, and then sine of 2 times half tan inverse of 2. Okay, then to 3 decimal places, you type it in on your calculator. I got 0.514. Okay, so that's about it on parametric equations. So far what we've done, there hasn't been anything too complicated. Applying standard derivatives or adding to our table of standard derivatives, and then you just have to know this is how we differentiate any function that looks like that and differentiate it in that way. So we now look at some more applications of derivatives. Again, this is more of a revision of what we've done last semester. Look at further applications of differentiation. The first one deals with linear motion. And in this case, we're talking about a body, an object that is moving in a straight line, maybe back and forth. And we are given an equation for its displacement. So we have an object that is moving in a straight line. With the displacement S that is given by S is equal to F of t. So our displacement is a function of time. Now, given the formula for the displacement, we can from there work out the velocity, excuse me, and the acceleration of the body. So the velocity, if you remember, is given by v is equal to ds dt. So what that means is you differentiate the formula of s with respect to t, and then that will give you the formula for the velocity. And then you can also work out the acceleration. How do we get the acceleration? You just differentiate the velocity with respect to time. And say that the acceleration is given by A is equal to dv dt, or simply differentiate. Somebody saying something? Okay, right. Or we can say that the acceleration is the derivative of velocity with respect to time. So we know by definition, when we want to find out what is the acceleration of an object, we're saying how is the velocity, it's the change of velocity with respect to time. That's what this derivative means. And here, just differentiate the displacement twice, and then that will give you the acceleration. So those are the two, which are in fact the same. So now we can look at an example or a reminder of what we did so far. So let's say we're given our displacement t cubed over 2 minus t squared plus 2, and then we have to find the velocity after 2 seconds, or when t is equal to 2. So we have the formula for the displacement. To get the velocity, v is just ds dt. So we just differentiate this with respect to t. This is a polynomial, very easy to differentiate. So this is 3 t squared over 2 minus 2t plus 0. So that is the derivative. Then when t is equal to 2, we just substitute 2 over there. So we're looking for the velocity when t is equal to 2. This is 3 times 2 squared divided by 2 minus 2 times 2. This you can do on your calculator. This gives us 2 meters per second. So the units are given to you in the question. So it'll say how many meters has it moved after 2 seconds or whatever, and then you put the appropriate units. So if we're talking about meters per hour or kilometers per hour or whatever the units are, make sure you put the units in the end. Then we also want to work out the acceleration after 2 seconds. So we know that acceleration is dv dt. So we take our formula for the velocity and then we differentiate it. So here when we differentiate that, we get 3t minus 2. That is our formula for the acceleration. And when we want the acceleration after 2 seconds, we just substitute 2 into our formula. So this is 3 times 2 minus 2. This is 6 minus 2, and that gives us 4 meters per second squared. Okay, so that is how we work out the velocity and the acceleration. Okay, and another example, number 2. We are told that a body moves according to the equation S is equal to t to the power of 3 minus 11t squared over 2 plus 6t minus 2. And here we're told that S is the displacement of the body after t seconds of movement. When is the body at rest for an instant, and what is its acceleration? So those are, I think, engineering physics terms, which I'm sure you are familiar with. So when we talk about a body being at rest, this means that it is not moving, so its velocity is 0. So we need to find the formula for velocity and then equate it to 0 and then solve for t. That will tell us when. So when somebody is asking you when is something happening, they're asking for time. So what we're looking for is time. So the velocity we said is ds dt, which is 3t squared minus 11t plus 6. That is the formula for the velocity at any given time. But we are told that the body is at rest, so the velocity is 0. So at rest, we have 3t squared minus 11t plus 6 is equal to 0. So this is a quadratic equation which we should be able to solve. You can factorize, complete the square, or use the formula, whichever method is good for you. So I will factorize. We look for two numbers. When you multiply them, the answer is 18. And when we add them, the answer is negative 11. So that's minus 9 and minus 2. So we put our variable t, and then minus 9, minus 2. And then because there's a number here in front of the t, we divide this by that number. Okay, so when we have factorized this, we have t minus 3, and then 3t minus 2, and this is equal to 0. Then we can solve that. This means that t minus 3 is equal to 0, or t is equal, or or 3t minus 2 is equal to 0. Okay, for the first one, this means that t is equal to 3. For the second one, this means that t is equal to 2 over 3. So that means it comes to instantaneous rest at 2 times. The first is after 2 over 3 seconds, and then at 3 seconds, it also instantaneously rests. So let me just see that question again. Okay, we just wanted to find the times when it is instantaneously at rest, and those are the 2 times. So we can write a sentence, say the body is at instantaneous. I hope that's how you spell it. Okay, so those are the 2 times that it comes to instantaneous rest. And then we are told what is the acceleration. So for the acceleration, if we have the formula for the velocity, all we need to do is differentiate. So our acceleration, this is dv dt. So this 3t squared minus 11t plus 6, that is what we need to differentiate. Doing that, we get 6t minus 11. Okay, and now we want the acceleration at each of those times. Okay, so the acceleration after 2 over 3 seconds, this is 6 times 2 over 3 minus 11. That you can work out on your calculator. I got -7 meters per second squared. So we know that when acceleration is negative, that is deceleration. And then after 3 seconds, we have 6 times 3 minus 11. This is 7 meters per second squared. So there it is accelerating. So when the acceleration is positive. Okay, and because these are vectors, the sign also indicates the direction in which the force is moving, if I remember from physics. Then we also have circular motion. So our motion need not only be restricted to linear motion, so it doesn't have to be just in a straight line. So we can talk about an object that is going round and round, and that is where we bring in linear motion. Okay, so the idea is the same in that if you have the displacement, you can work out the velocity by differentiating. And when you have the velocity, you can work out the acceleration by differentiating. Except this time, instead of measuring our displacement in meters, we measure our displacement by as an angle. So here we have theta is equal to f of t, and theta is the angle subtended at the middle. The middle of the circle by the arc which the particle has moved seconds. So our body is moving like that. So this is our body over here. That is where it starts. And let's say after t seconds, this is where it ends up. So it's moving maybe in that direction. So this theta over here, that is the displacement that we are talking about. Okay, so it's no longer a straight line. We're talking about the angle that is subtended over here. That tells us the displacement of our angle. And like I said, the angular velocity is given by omega, which is just d theta dt. So we work it out in the same way. You differentiate theta with respect to t, and then our angular acceleration this is d omega dt, which is also differentiating theta twice with respect to t. So the idea is the same. Okay, so we'll stop here for today, and then tomorrow we'll look at some examples. Again, pretty much just a revision of things that you have done last semester. Okay, and yeah, we don't have too much to cover until the test. I think the test is sometime next week or the week after that. Okay, so we still have some time. Okay.